Trigonometry, section 5.6, the half-angle identities. First of all, let's give you what you would give me on a quiz that can happen anytime. The sine of a over 2 is plus or minus the square root of 1 minus cosine a over 2. Make sure you show that everything is under that radical. You also need the plus and minus for the cosine of a over 2, plus or minus the square root of 1 plus cosine a over 2. Make sure everything looks like it's underneath the radical. The tangent. Now in the book they use 3 of them, but we're going to just stick with 2. It is the sine of a over 1 plus cosine a and 1 minus cosine a over the sine of a. Now you might be saying, oh gosh, how did you get that stuff? Well, that's the next part. So, in order to get these sines and cosines, so we can use that for the tangent, we have to remember, because the double angles will help us. Not the sine of 2a, but the cosine's double angle. For this one, remember the cosine of 2a was 1 minus 2 sine squared a. And it's important then to recognize that this angle is twice that one. So if I change that and say this is the cosine of a, I have to write the sine's argument as a over 2. 2a twice a twice a over 2. And then solve for sine. So first of all, subtract 1 from both sides. That gives us a negative 2 sine squared a over 2. And then divide both sides by a negative 2. Well, if we divide by a negative, we're going to switch the signs here. So I'm going to say it's 1 minus cosine a, look familiar, over positive 2. And that is the sine squared a over 2. Well, we don't want sine squared. We want just sine. So you take the square root of both sides. But remember, when you take the square root, you have to at least consider plus or minus. And this is important, especially here, because the cosine is not the same positive and negative signs as the sine. So you got to know where this angle is at for the half angle in order to make sure that you get the plus or minus sign correct. So that's how we get the sine. Similarly, with the cosine, we're going to use the other double angle for cosine. That's the 2 cosine squared a minus 1. And once again, this angle is double that. So we're going to just call this cosine a. So this cosine squared is a over 2. And now we add 1 to both sides. So we get 1 plus cosine a equals 2 cosine squared a over 2. And then divide both sides by 2. So 1 plus cosine a over 2 is the cosine squared a over 2. And once again, take the square root of both sides. When you take the square root, you need plus or minus. Because this half angle, a may put you into the next quadrant. You need to make sure you get the correct sign, plus or minus. And that's where the second one comes from. So you might say, well, hold it. Then where does tangent come from? Well, let's see here. The tangent of a over 2 is the sine of a over 2 over the cosine of a over 2. And the sine of a over 2 is plus or minus the square root of 1 minus cosine a over 2. And the cosine of a over 2 is plus or minus the square root of 1 plus cosine a over 2. Now when you invert and multiply, because you can put this whole thing, oh, by the way, these plus and minus signs take care of themselves. You no longer have to worry about the plus and minus. You can have this real big. If you invert and multiply, It's really 1 minus cosine A over 2 times 2 over 1 plus cosine A. Well, these 2's cancel, right? It's a really horrible way to write that, but I'm squeezing it in. That gives us one of the forms that the book uses, 1 minus cosine A, take that square root, over square root of 1 plus cosine A. Because that one is so obvious that we just have to put these over each other, we're not going to memorize that one. You can memorize it anyway if you'd like. How do we get these other two? Well, it's not too bad. We have to say, first of all, let's multiply both numerator and denominator by the numerator. So the square root of 1 minus cosine A over the square root of 1 plus cosine A. We're going to multiply by this 1 minus cosine A, both numerator and denominator, because then we'll just be multiplying by 1. Now you get 1 minus cosine A times 1 minus cosine A, which is 1 minus cosine A squared. So when you take the square root of something squared, it's just that 1 minus cosine A. This is like the square root of 2 times the square root of 2 is just 2. This one's a little different. This gives you the sum and the difference, and you get the squares of each. 1 squared minus cosine squared. But hold it. 1 minus cosine squared is the same as sine squared A. But hold it, this was square root, so that denominator just becomes the sine of A. So, 1 minus cosine A over sine A. The other one is very similar, but now we multiply both numerator and denominator by the denominator. Square root of 1 minus cosine A over the square root of 1 plus cosine A. This is times this denominator, 1 plus cosine A. Square root of 1 plus cosine A. So we're just multiplying by 1. Once again, the denominator is sort of easy because this is like square root of 2 times square root of 2 is just 2. This is 1 plus cosine A. Once again, the sum and the difference give us the squares. 1 squared minus cosine squared A. But hold it, that's the same as sine squared A, which we need the square root of over 1 plus cosine A, or the sine of A over 1 plus cosine A. So how do you memorize these? I guess these first two are almost the same. For the sine, it's subtraction. For the cosine, it's addition. So if you memorize one of those, then you got the other one. You also remember this is 1 minus cosine A over 1 plus cosine A when you do the tangent. And just remember the other one will be just sine. So it's either the 1 minus cosine A over the sine, or the sine over 1 plus cosine A, because that's where the 1 minus cosine A is and the 1 plus cosine A is. Those are the half angle identities. In the next few examples, I'll be able to show you how we're going to use those. Trigonometry, section 5.6, example problem number 16. Find the exact value of the sine of 165 degrees. Well, first of all, since we're in the half angle formulas, this must be a half of an angle. If we double that, 2 times 5 is 10, carry the 1, 12, 13, carry the 1, 2, 3, 330 degrees. So, what are we talking about? Well, our actual angle, 165, is in the second quadrant. But we're going to use double that, the 330, in the fourth quadrant. And we know that 30 degrees is the reference angle for this angle in here. So we're going to use the sine of 165 degrees equals plus or minus the square root of 1 minus the cosine of 330. That's double this angle. This is half the 330 over 2. Now, let's see. 330 has a reference angle of 30 degrees. What is the cosine of 30 degrees? Well, you can look it up. The square root of 3 over 2. Now, this is in the fourth quadrant, but the cosine is still positive in the fourth quadrant. So this is plus or minus the square root of 1 minus the cosine of 30 degrees over 2. Oh, we also might mention the sine in the second quadrant is positive. So I'm going to just use the plus there. So this is 1 minus the square root of 3 over 2 over 2. So let's work here to the side a little bit. Square root of 3 over 2 over 2. Oh my gosh. 1 minus the square root of 3 over 2 is the same as 2 over 2 minus the square root of 3 over 2. Which is 2 minus the square root of 3 all over 2. Now when you divide by 2, you really multiply by 1/2, right? So this is really 2 minus the square root of 3 over 4. So we get plus, for our final answer, this is 2 minus the square root of 3 over 4. But the square root of 4 is 2. So it's a positive answer. The square root of 2 minus the square root of 3, now outside, over 2. And there we've gotten rid of that fraction under the denominator. And that's the exact answer. Trig, example problem, number 26. Find the following. The cotangent of theta over 2, given that the tangent of theta is equal to a negative square root of 5 over 2. And theta is between 90 degrees and 180 degrees. Well, let's first of all take a look at that. If theta is between 90 and 180, then theta must be in the second quadrant. Okay. We know about the plus and minus signs in the second quadrant. Now, if the tangent is of theta is a negative square root of 5 over 2, how do we label this right triangle? Well, this is opposite over hypotenuse. I'm sorry, opposite over adjacent. But the opposite is not negative, that's positive. So this is a square root of 5, but the negative is in the denominator, negative 2. And r is what we need to find. So negative 2 squared plus the square root of 5 squared is r squared. This is 4 plus 5 is r squared. 9 is r squared, so I guess 3 is r. So, and r is always positive. So now that we have this triangle, we can come up with the answer to our question. First of all, we don't have an identity for cotangent. So we just say, first of all, it's 1 over tangent theta over 2. And the tangent of theta over 2, we can choose one of the two. I'm going to choose 1 minus cosine theta over sine theta. But since it's 1 over that, you invert and multiply, and you get sine theta over 1 minus cosine theta. So in order to find the cotangent of theta over 2, we use the tangent of theta over 2, its reciprocal, and we need the sine and the cosine. Let's see here. So the sine of theta is the opposite over the hypotenuse, square root of 5 over 3. That's positive in the second quadrant. The cosine of theta is the adjacent over hypotenuse. That's a negative 2/3. Cosine is negative in that second quadrant. So this is the sine square root of 5 over 3 over 1 minus a negative 2/3. So that's really 1 plus, right? Square root of 5 over 3 over 1 plus 2/3. Well, 1 is 3/3. So this is the square root of 5 over 3 over 5/3. When you divide by a fraction, you multiply by the reciprocal. So you multiply by 3/5. 3's cancel, and you get the square root of 5 over 5. And 26 is done. Trigonometry, section 5.6. Problem number 38 as an example. We've got this expression, and we're supposed to simplify it. Well, when you look at that, you realize that this is an identity. It is equal to the tangent of the half angle. This 158.2 over 2. So if this is the whole angle, then this is the half angle. Tangent, half of this is 79.1 degrees. So that's the end of 38. Let's do another one on this paper since we got some room. The verification, which one do we want to choose? Let's do 48. So we want to verify that the sine of 2x over 2 sine x is equal to the cosine of x, cosine squared of x over 2 minus the sine squared of x over 2. Okay, so I'm going to take one side and make it look like the other. Well, we got a choice this time because these are half angles. And this is a double angle. So what I'm going to do is say, I think I'm going to work on the right side because the half angles are more complicated. This sine 2x, what I'm going to think about, without writing down, of course, sine 2x is 2 sine x cosine x. This denominator is 2 sine x. So if I can get to something like that, then I'll be done. Cosine squared, remember, cosine of x over 2 is plus or minus the square root, 1 plus cosine x over 2 squared, minus the sine is plus or minus the square root of 1 minus cosine x over 2 squared. And these squares take care of the plus and minus signs, takes care of the square root. So 1 plus cosine x over 2 minus 1 minus cosine x over 2. They have a common denominator, but be a little careful of the subtraction. 1 plus cosine x minus 1 plus cosine x. That negative affects that too. All over 2. So the 1's cancel. This is 2 cosine x over 2. Which the 2's also cancel. So you say, well, heck, I just get cosine x. Well, remember, this is what I was thinking before. If I multiply both numerator and denominator by 2 sine x, or maybe I could have left the 2 there and just multiply by sine x over sine x. Same thing. I get the 2 sine x cosine x over 2 sine x. But remember, 2 sine x cosine x is sine 2x over 2 sine x, which is what we had here, sine 2x over 2 sine x, QED.